Having created the basic test device file during categorization, you're now ready to add or check pin information. To do so, you need to open the file in the editor. From the Categorize Devices screen, right-click on the test device file you're working on and select Go To from the context menu. That'll transfer you to the Test Device Files screen with the file opened. Pin information is entered in this Buses tab, so make sure you've got that selected. In the previous video, you saw how XJDeveloper could create the file based upon a device and how it could insert a basic I2C test for you. If you allowed either of those, XJDeveloper will already have created buses for you and named them from the nets connected to the device. Check them and edit any you want to by double-clicking in the appropriate cell. If you created an empty file, you'll need to add the pins manually. Click Create Bus at the bottom to make a new row and type the data directly into the cells. Keep doing that until you've put in all the pins you're going to interact with. Other pins don't have to be included, but it's good to add all the pins that could possibly be used. That helps with reusability because the file will then also be applicable when the device is used in different circuit configurations. For example, on your board, you might have a write protect pin tied high, but a board in the future might allow you to control it, so it's worth including it in the list. You've got to give each row a name and details of the pin or pins it contains. When you're entering more than one pin, separate them with commas. If it's a multi-pin bus, like an address or data bus, enter those pins in order, with the most significant bit on the left. An example of when you might want to group pins together is if you've got a device with several output enable pins. Grouping those pins into one bus makes it easier to manipulate them. Even if XJDeveloper created bus entries for you based on net names, you may find you still want to set up some additional groups of pins to make testing easier. You don't have to include the power and ground pins or any pins that aren't connected, but it can be helpful because it makes it easier to check you've got the file with the correct pinout if you use it later to categorize another device. Now let's look at the next column. You saw what a disable value was and when you would want to use it in the second video of this series. Now let's look at how to set one up. The default setting is None, and that'll be correct for the majority of pins. It means Connection Test can control those nets however it wants during the test, so you want to keep as many pins set to None as possible, because that'll give you the best test coverage. If you do need to hold a pin in a fixed state during the test, set it to High or Low as necessary. If something else can't be prevented from driving the net, then you'll want to set the disable value to Excluded, so that Connection Test ignores what it reads back from that pin and doesn't allow anything under its control to drive that net. Any values you set in this way will be applied at the end of the JTAG chain initialization. They can be overridden by an XJEase function, but running Connection Test or Safe will reset them again. The final column is Tested For. XJDeveloper can't infer what XJEase tests are checking buses for, so this column allows you to provide that information. The values you enter don't impact the test itself, but are used in the test coverage calculations. To enter the data, double-click in the cell and select the options from the drop-down menu. For example, a test function that can read a pin to check its high or low when expected can detect open circuits and stuck-it faults, so you would tick those boxes. The Functionally Tested option is relevant when a pin is tested indirectly, rather than by controlling the pin. For example, take this ADC. It's unlikely you'll have boundary scan access to its analog inputs, but it might still be possible to test them if they're connected to a known voltage because you could read its ADC channel. In that case, the analog inputs can be listed as being functionally tested. There's one final point to note about bus information. So far, we've considered the case when the test device file only needs to control the pins on that particular device, but sometimes you might also have to control a pin on another device. For an example, take this micro SD card connector. The power to the SD card comes from a separate regulator with its own enable pin. If the board is tested with the SD card fitted, you can check the connector by using some of the card's functionality. In that case, you would categorize the connector using the test device file for an SD card, but when it comes to the VDD enable pin, you would, instead, enter the enable pin for the regulator. In this example, pin 3 of U1. So you would type U1.3 for the pin on that bus. You can then use code that already exists in the library file to control that pin and turn on the regulator as part of testing the connector. The alternative method for controlling a pin not on the device is to use what's called a circuit code file. Like test device files, they contain XJE's code and can call functions from test device files, but they don't define a specific part. Instead, they apply to one particular implementation of a circuit and are frequently used for tests that involve more than one device. Let's take another example to demonstrate when you'd use them. Say your board's got a pair of RS485 transceivers. They'll both be associated with the same test device file, which contains functions for things like controlling their outputs and setting them up to detect received signals. But if you want to do a loopback test that sends data between the two devices, your test needs to have call statements to access the two specific devices, U2 and U3. The test is therefore only applicable to those two devices and how they're connected during the test. In that situation, it's a circuit code file you need to use. The file would call functions from the test device file to set one transceiver up to read and the other one to transmit, and would then check that signals sent from one device are detected by the other via a loopback. In XJDeveloper, the circuit code files being used in your project can be found on this screen. And with that, it's time to move on. Now that you've covered what you need to know about entering bus information, we'll look at writing test functions. You'll see how to do that in the next video.